Hello everyone, so now we are going to do the IPSLA. If you see configure verify IPSLA. So SLA is nothing but service level agreement. So IPSLA, IP stands for Internet Protocol, SLA is nothing but service level agreement. So generally whenever we have the agreement from the ISP, we will have the SLA. I will say I need this much speed in the internet, I should have this one. They will agree and we will sign the contract. That is generally we are calling service level agreement. What we can say, service level agreement is a formal or informal contract between the two parties. And we have one feature also in the Cisco router IPSLA. So with that one we can monitor or we can check our network performance. Generally we are using this one for network performance measurement. If you want to measure our network performance, like how much speed we are getting from the ISP, and if you want to increase the bandwidth, you can cross check with this IPSLA and you can plan for increasing the bandwidth. But in the most of the cases we are using this one for what we can say when we have the two ISP connection. So first we need to remember IPSLA is nothing but Internet Protocol Service Level Agreement, and SLA stands for Service Level Agreement, that is a formal or informal agreement between two parties. And this is a feature, that is IPSLA, available in the Cisco router or the switch, what we can say to perform the periodic measurement. And we can check or we can collect the data and we can verify ISP is providing us the speed, it is okay, or if it is having the service down or it is okay, we can measure with this SLA feature. It is available in the Cisco iOS device. So how we can measure? We can ping some server in the internet and we can measure how much time it is taking to go ping and come back to us. So with that one we can apply more policy like static route. Example, if you want to what we can say, we can configure to static route, and automatically we want to change the static route when ISP is down, we can use IPSLA to do that one also. Policy based routing also we can do with the IPSLA. So if we have so many things, we can measure ICMP, we can take real-time protocol, we can use TCP, UDP, so many things we can use. But the example, most important thing in our network where we are using this one is when we have the two ISP. If you see here, in the general scenario, what we will do, this is our router and I have one ISP here. I will configure the default route here. I will forward my all traffic here in the ISP. I will put AD value as a 1. This is my secondary, that is a backup connection, that is the second ISP. If this link go down, our traffic should go here. So what we will do, we will put the AD value as a 2 here. So wherever AD value is low, that one is going to prefer. So this one is going to prefer, but when this link go down, automatically our traffic will go here. Okay, this is a scenario generally. But in real scenario, the ISP cable will not terminate on the router. Generally, we will use the MUX or DMUX or switch here, and ISP cable will connect here, and our customer cable, the router will connect here. If you see in the scenario, what we will have, if anything go wrong in the ISP, our route will not change. Why it will not change? Because we are using switch. Let me show you this way. If you see this scenario, I am saying this scenario. If we see this one, okay, this is our scenario. Okay, this is our scenario here, our router, company router, this one, and this is our switch. If we have link directly connected like this, if this go down, automatically we will jump to this one. Example, imagine we have two direct connection. Don't look this one, think you don't have this one, you have directly two connection like this. Okay, you have a default route, you configure the default route, that is static route. Static route is nothing but default route. You are saying all the traffic will go here. Okay, 0.0.0, 0.0.0 will forward to this IP. Okay, and you will put AD value as 5 here, and here you will put the AD value as a 10. So this route will be removed from the routing table. Whenever this link go down, automatically this route will go away and this new route, the AD value 10, will come up. This is good, we are happy. But in real scenario, we will not have directly connection. We will have the mux or demux in between your router or switch. You have switch here. In the switch, ISP will terminate the cable, and ISP2 also terminate the cable in the switch, and from the switch you will have the router. So now you have the static route, you have the, that is the default route you have, saying that traffic should go here and AD value will be 5, and you have one more from here, the AD value will be 10. So in your routing table you will see this, okay, it will appear, it is having this one. Even if this link go down, it will not remove from your routing table, because they are checking the interface. This interface is up, this interface is up, they will think it is up only, and he will, even if this link go down, it will not remove from the routing table. So your traffic will drop. When this link go down, your router will think it is up only. Why? Because they will check the directly connected link. This is directly connected, so he will not switch, he will not change. So in that scenario, you will have the issue. So what we will do, we will run the IPSLA. In the IPSLA, what we will say, if the I am going to ping to this IP, if reply is not coming in particular time, then if it is not coming in particular time, then switch from this ISP to this ISP. How we will do that one? By using IPSLA. So this generally in the real scenario we are using these types of situation, but you can use for so many things also. If you want to measure the performance of the network, we can measure also. Example, I wrote here theory, we can do that way also. If you see here, what we can say, we can ping and we can get the reply back, and we can measure in how much time it is coming back. With that one we can check our network performance. We can run so many things. We can use UDP, DNS and DSCP, HTTP, FTP, so many things we can measure the response time, how much time it is taking. But in the real scenario, in the companies especially, we are using this for the ISP when we have the two ISP. So what I will do, I will create one scenario, I will show you that one, okay, so you will have more ideas. So what I can do basic lab in the packet tracer also. Advanced lab we need to do in GNS3 or EVNG. So let me do here only. What I will do, this already close. So now let me create the new lab. I will give the name as a IPSLA. IPSLA. I will create the scenario here, okay. What I will do, I will take one router. This is our company router. I will take, this is ISP1, ISP2, and we will take one switch also. But before switch, I will use without switch also. I will show you. If we have without switch, no issue, we will not face any issue. We will do the both the way, okay. So I have one here, and let me check something. Window Defender has blocked some feature. You can see the screen, right?
Yeah.
Okay, maybe I am using with another internet, so maybe we have some issue. Okay, so now first we will use this scenario, and I will show you what is the difference between the normal scenario and the real scenario. So I will make this as a our router, the customer router we can say, or our enterprise router or gateway, anything we can write. I will write GW, gateway. So this is our organization router, we are saying gateway, and this one we can see ISP1, and then I can say this is a ISP2. Okay, so this is a ISP1, ISP2, here ISP1, ISP2. So let me start this router and take the console. I will start this and this, and I will take the console also, and let me give the IP schema. I will give here example same as we do before, 192.168.1. or I will use 12.0. okay, so this will be 12.0, and here we will have the 13.0. okay, so this way we can use here and here I can create the loopback, and I can give here as a internet as 8.8.8.8. Excuse me. So this one, like this, we are going to use this scenario. So what I will do here, this is the R1 and we have the R2. We don't have R3, I think. Yeah, we don't have. So this is a two router, R1, R2. Later we are going to use the switch also. Let me reduce the size. Okay, so this is a topology. What I am doing here in the R1, I will in the R1, where is R1? R1 I have ISP1. Let me close and open again. Maybe that is wrong. Okay, now this is one console. Okay, and we have another console, this one, and I will take one more console here. So I have total 3 console here. Okay, so now we will do the configuration, basic configuration. First of all, what I will do, I will go here, configuration interface for, let me enable the ports F0 by 0, F1 by 0, this is F0 by 0, this is also F0 by 0. So what I will do here, interface fast Ethernet 0 by 0, IP address 192.168.12.1, 255.255.255.0, and I write no shut this one. Another interface fast Ethernet 1 by 0, IP address we write 192.168 and what is the number, 13.1, 255.255.255.0, and we will write no shut here. So just we created 2 interface here. And after that, what I will do, I will create the default route. I will write IP route 0.0.0 and then 0.0.0. And what I will do, I will write the next hop IP. So one is 192.168.12.2. Okay, this one I am saying I will forward all traffic here 12.2, and I will put here AD value. If you see here, administrative distance we can keep here, so I will put here 5, AD value will be 5, and I will create one more route. I will write same like this, and I will change here the, here will be 13 dot I will write 3, and here I will write 10. What I am doing, let me explain again. See here, I am creating 2 default route. I am sending one default route to ISP1 saying that 0.0.0, 0.0.0 forward to 192.168.12.2 here, and I am sending another traffic. I am saying that like 0.0.0 forward to this IP. This is 13.3, but I am putting AD value as a high AD value here. So this will be prefer, and this will be as a standby. If anything happen wrong to the first one, then our this will be removed from our routing table. We will have this one in our routing table. For that purpose we put 2, and here I will go to the ISP router. I will create here, I will go interface fast Ethernet 0 by 0, and then I will write here 0 by, let me check, interface fast Ethernet 0 by 0, and IP address 192.168.12.2. okay, 255.255.255.0. no shut, do show IP interface brief, we will check. Okay, so this one is good, and now I will create one more loopback 0. I will write IP address. Why I am creating loopback 0? Just to have the internet connection, just to indicate Google server. Here I am saying Google server. So what I done, I created 2. I will write show IP interface brief. So now I have the 2 interface fast Ethernet 0 by 0 here, this one, this IP, and this one is a loopback, this one. Okay, just basic I assign here. Same thing we will do here. I will go here in the interface fast Ethernet 0 by 0. I will write here IP address, and what IP we will have 192.168, I think 13.3. and 255.255.255.0, and you write no shut here, and then interface loopback 0 just to indicate Google server. I will write IP address 8.8.8.8 and 255.0.0.0. okay, so here also we assign 2. Show IP interface brief, so we can see we have the 2 server. And if we check here like show IP root, we will see we have the default root. We are getting this one, that is 5. AD value is 5, that means this one, the above one, this one. If you have confusion, I will put here, this is the .2, this one is a .2, this IP here, this router is having .2 and this one is having .3. okay, I think now it is clear for everyone. And here will be .1 for all, this side also .1 and this side also .1. okay, so now when I check here, if you see when I check here, I am getting this root from 12.2. so whenever I want to ping anything, I will go from 12.2. example, I am pinging 8.8.8.8, it will go there, it will have the reply, it is going. If I want to track, I can write trace root and I can give 8.8.8, it will show me I am going from 12.2. so this is a 12.2. okay, but problem, if the 12.2 is a ISP, what we can say ISP1. okay, in the ISP1, imagine I will go to the ISP1 interface fast Ethernet 0/0. okay, and I will write here shut. When I put the shut, if in our routing table, it will remove. okay, if I check here in the routing table, this root still we have, now it will remove and you will have the another root. Still you have, we put the down this link, right? Why it is still there? Let me check here which one I put down. ISP1 fast. Let me check here which one I put. Show IP interface brief. If you check here, I make this fast Ethernet 0/0, this link as a down. okay, so if we go here, it will remove from our routing table, but still it is not removed. It should remove. We should have the new entry. This 5.1 is there. Let me check it is done or not. This already done. Show IP interface brief. Let me make up and down, or maybe some issue with the GNS here. Let me go and put this interface down from this side to show you. I go here, I write shut. okay, now we write do show IP root. If you see, now we have this entry. okay, you have the entry from this side 10. If this ISP is down, so we have the entry from this ISP. Automatically it is changing when we have this link down, because they will check the link. If link is not available, then they will move. okay, and if I write here no shut, and if we check again, let me check here, show IP root, we have again back this one. If this link go down also, we should have the issue, but I don't know why in this one they are not taking this link. If this go down, automatically they will go down, but maybe we have some issue in the GNS. Anyhow, when I make this interface down, it is removed from the routing table, and we have the other one. If you see here, which one we have just now, this one from 13.3. so automatically it will change. Example, what I will do here, let me check here, show IP interface brief. So even if I keep this interface down, it is having some issue. Fast Ethernet 0/0, I will write no shut. So now imagine show IP interface brief. So we have this interface is up, this interface is up, so our root should be from here, this side. And if I write show IP root, if I check, it is going to 12. But if this interface, this link go down, if you see, if this link go down, our default route will change from this direction to this direction. It will become here 10 and this will be from 13.3. okay, automatically it is changing when it is directly connected. But if imagine if you have one switch here, then it will not change. So what we need to do, we need to configure the IPSLA in that scenario. So what I will do here, and if you have confusion, let me show you again what I am saying. Example, imagine this interface fast Ethernet 0/0 go down, fast Ethernet go down. When it go down, what you will have, when you check show IP route here, you have the default route move from the ISP1 to ISP2, and this is a ISP2, and AD value is high here. Okay, and when that route come up again, it will again go to the ISP1. If you want, let me show you. I have read show IP route. If you see, again it go back to ISP1 because of the link. But now in the real scenario, you will not have this directly connected. Whenever you are connecting to the ISP, what you will have the switch in between. So in the real scenario, you will have the switch or mux or demux. So imagine this interface is connected here. Okay, and here I will take one interface, it will connect here fast Ethernet 0/0. Here this one will connect to fast Ethernet 0/0. So in the real scenario, we will have like this. In the real scenario, we will have like this scenario. We will have the switch. We will have the switch. So if you have the switch will not, if this link go down, they will not treat, because they are thinking this directly connected link. If this link is up, they will think this is also up. Okay, so now what I will do, I will show you here. Imagine I am here inside, I will write here show IP route. Okay, so now I am getting the route from here. Okay, I am getting the route from here. Let me ping and check. Ping 8.8.8.8. Ping 8.8.8.8, and let me check the switch is on or still it is putting up. Switch is on. Now it is on. So let's see here, it is working. It is working. Okay, so whenever I am pinging, it is working from the gateway. If I do the trace route also 8.8.8.8, it is working. It is going from the ISP1. Now what I will do, this interface I will make down. Okay, if I go to the switch or I go to the ISP, I will go to this interface fast Ethernet 0/0. I make this interface down. Even if I make this interface down, it will not show here in this one. If you go here, show IP route, you will have the same route. Even this interface go down, it will not show you. And if you check the show IP interface brief, your interface is going to show up. If you see here, this 12.1 is showing up. 12.1 is showing up here. Why 13.1 is showing down here? Okay, this one we are not using now. We are using this interface only, one interface. So let me do the sub interface and show you. So what I will do here, let me do some basic configuration. I will create VLAN 10 here. What I am saying, we will create the VLAN 10 here, or VLAN 5, any VLAN, and here I will use the VLAN, any different VLAN. So this is having some VLAN, this is having some VLAN, and we will put in the sub interface from here. Then we can apply the IPSLA. But basic thing what I want to say you, I am saying if I want to access, if I am connected like this way to the ISP, but if this link go down, automatically it will not switch from there to here. It will not go here. Why? They will check directly connected. They will say if this link is up, our network is okay. They will not remove this route from the routing table. So what we need to do, we need to configure the IPSLA. So IPSLA is going to ping to this interface. If this interface is not working, then automatically they are going to switch to this side. This we need to do. Okay, so what we can do, we can configure that one. IPSLA we can configure. So this is in the real scenario, we are using that type of what we can say situation. Okay, So here what I can do for that scenario, let me create this topology also we can use, but here we need to change some IP modification. So let me use that IP here. I will delete this one. Let me put the new IP schema, or we will create the new topology. Let me switch off this one. We will do in the EVNG, because in GNS just now we face some issue also. So what I will do, now you have the basic idea, right? What I want to say, what issue. If you are having still doubt, I can show you that one in the EVNG. GNS we can do that, or EVNG. Let me show the in the EVNG we can do that in EVNG. The concept is important, the basic thing, and we can verify here. Okay, let me check. I start this or that. This machine is having low space, so let me switch off this one. I will start this one. Okay. So now we will do one scenario and we will check. I will show you it will not switch from one destination to another destination. So what I will do, let me take the IP. Take the IP, I will put this IP here. 192 dot, let's see what will be the IP here. 192.168.43.166. Okay, so this is my IP. So maybe before I do this lab, so maybe if we have topology, we can use the same topology here. Let me check here in the CNP IPSLA. If we have IPSLA, yeah, here, so we can use, but here I have only 2 router. We need more, so let me check IPSLA. Anyhow, let me create new one. IPSLA lab 1. Okay, so now why I am doing here, because just now we check in GNS3 we are having some issue, but anyhow we manage and we check the output. So now I will take the router. We need 3 router. Okay, so here quantity 3, and here I will give the R1 R. So now this is a 3 router. We can say this is the customer edge CE. This is a CE, okay, customer edge. And now I can say this is the ISP1, and here I will say another is a ISP2, Now what I can do, I can take one switch here, IOL, this one, and this image we can change. We can change the image, switch any image I can select. Okay, and here I will write the SW1, and you can select here. This is the switch image. I run this one. Other image is having the router also here. So symbol I did not change. Let me change the symbol here. This symbol I will select. Okay, now I will press OK, and then we will connect here. So I will use E0/0 to this router, fast Ethernet 0/0, and here this one is a fast Ethernet 0/0, E0/1, and here I will take this one as a fast Ethernet 0/0. Okay, so now we can start the router. I will start this R1 switch also I will start, and this ISP1, ISP2. Okay, so now in the real scenario what we will do, let me move in the real organization also. We will have the 2 ISP like this. Let me move this up here. Okay, let me take any IP schema here. I will use the simple one. Just I will take 1.1.1.1/24. I can increase the font size here, bolds, or here any color. Excuse me, this one I am using here. This should be this side, and here I am using the other side is this one. Here I can create the 2. This one has a 2 here, and let me make the duplicate here also, and this I will keep here. Maybe I will take the 3 here, 3. Okay, and now I can create the loop back here. I will keep loop back just in case. This is a loop back 8.8.8.8. okay, and I will move this here also. So this is our scenario. Let me start this, and also we will create the VLAN also. Let me put the label here so I can differentiate here. Okay, I can differentiate, or let me put the IP schema. This one I am using here, right? This is the one IP, and here what I can say, because 2 different ISP can give you 2 different IP, not the same network. So what we can say here, from here to here, this IP give by one ISP, okay, but here should be different ISP. So this is different ISP, so they will give you different IP. So I will put here different IP. I will use, instead of 1.1.1, here I will use 2.2.2.1/24, because this is a different ISP. You get the IP from the ISP. ISP will say you what they will say. They will ask you, put this IP to your router interface and point out your default route towards this IP. Okay, so now here I will do this as a 2. So your ISP give you, this ISP is separate ISP, this is the separate ISP. They give you this public IP, and they told you put the default route and forward the default route to this IP. And another ISP to give you this one, they told put this IP to your interface and forward the default route to this ISP. But you will think, how I can assign the 2 IP to one interface? So we will use the sub interface. In firewall also we can do that one. So we will create the sub interface, and what we will put here, we will do the VLAN. We will put this port in different VLAN, this port is in different VLAN, and we will create the sub interface. So let me make duplicate here, and I will write here. Imagine this is the VLAN 5. So we will really, in the real scenario, we will have like this type of situation only. And here I will create VLAN 10. So this port should be in the VLAN 10. So I will create here VLAN 10. And now this port, the other port, we will make this one should be in trunk. So this port should be in the trunk. So I will write trunk here. Okay, this is a scenario we have. I will move this, so this one, and this should be in the trunk. Okay, like this. So let me take the console of this our router. This is our router, and here I will write no, and I will press enter. It will load, and if you want to log the lock, so the device will not move from one place to another place. This is router R2, and this will be the router R3, and here we will write, and then this will be the switch, and switch we need to wait. Here switch came, so I will do basic configuration. In switch, what we configure, I will write in the notepad so you can observe also. Okay, so I will take the notepad, I will start the configuration. Here I will write IP lab is IPSLA. Okay, here enable config T, or let me write here R1 configuration. R1 configuration. Here I will write interface, we will do sub interface. So first I will write host name CE. Customer age, I am giving the host name as a CE. We can use anything. And now how we will create sub interface? we will go first of all in the main interface. Main interface is fast Ethernet 0 by 0. We will write no shut, and we will not assign any IP. Okay, and after that I will write interface fast Ethernet 0 by 0 dot 5, because we are using VLAN 5, and then we need to write encapsulation. If we did not write encapsulation dot 1Q, we cannot assign the IP address. So we need to write encapsulation and dot 1Q, and then we need to give the tag. This tag will be 5 because VLAN 5, and then I will create one more. We can assign IP here. So this is the IP address. ISP give us 1.1.1, okay, and 255.255.255.0, and then we write here no shut. Okay, this is a first interface, this IP sub interface. Whenever we create the sub interface, we need to put dot and any number. So I am using this number as a 5 because I am putting this for the VLAN 5, and this port should be in the VLAN 5, and this IP as per the ISP told me assign this IP to your interface and forward the default route towards this IP. So for that purpose I have only one interface, so I cannot assign the two ISP IP. So what I done, I am doing the sub interface, and I am putting this in the one VLAN, and same sub interface tag I will put as a VLAN 5. This is in VLAN 5 and this tag will be in the VLAN 5. So now I will do the second sub interface. So how I will create, I will write here dot 10 because I am using VLAN 10. Here if I write any other number also no problem, but here tag should be same. And here ISP give me the IP. What IP he gives? 2.2.2.1. So this is the IP from the ISP. Okay. So this is a configuration of our router. What I done here, just I assign the sub interface and I assign the IP. Now let's do the switch configuration. So switch SW configuration. So switch configuration is simple. Just we need to write enable config t host name. What is the host name? SW. And then in the switch we will write the interface E0 by 0, interface E0 by 0, and then switch port mode trunk, like that. Let me write here switch port mode, but we need to write because this is a layer 3 switch, so we need to write switch port encapsulation dot 1Q. Okay, and then we can write switch port mode trunk. So what I done, I make this interface as a trunk, and then we need to put this interface in VLAN 5. This will be in the VLAN 10. So interface E0 by 1, I will write here switch port axis, switch port mode axis, and then switch port axis VLAN 5. Okay, VLAN 5. First of all we need to create also VLAN here. Even if we did not create, automatically it will create. So I will give a name as a VLAN 5 ISP 1, and then I will create VLAN how much, 10, VLAN 10. I will give the name as a ISP 2. Okay, and now this I put in the VLAN 5. So now I will copy this whole thing, and this other interface is 0 by 2, and this should be in the VLAN 10. So I will put here as a 10. Okay, so what else we can do here? We put the trunk, this one as a trunk, and we put this in the VLAN. That's all. Okay, and then in the ISP, what configuration we can do? We can write here example. This is a ISP 1 configuration. Here enable config t host name ISP 1, interface fast Ethernet 0 by 0, and we will have IP address. What will be IP address here? IP address will be what they give, 1.1.1.2, 255.255.255.0, and then no shut. Interface loopback 0, IP address 8.8.8.8, 255./8, or what we will use. Anyhow, I will write /8 only. Okay, so this one, this is a loopback. So this is a ISP1 configuration. Now I will do for the ISP2. ISP2 configuration will be, this will be 2, and this will be 2, and this will be 2 only, 2.2.2. Okay, all other thing remain same. So this is the ISP2 configuration. Now I need to create the default route also, so I will write here IP route 0.0.0 0.0.0 and I will write 19. What is the IP? 1.1.1.1 1.1.2. okay, and here I will give 5, and same thing I will create the default route. Any one more default route I will write here, and I will write here 10, and that will be here 2.2.2. okay, what I am doing here, just I am creating default route. One default route will go here with the ID value 5, other default route will go here with the ID value 10. okay, I am just putting the default route. Later we will remove again and we will do that one, but just to show you the scenario. So now I will copy from here to here. I will paste this in the R1. Let's see if we have all the spelling, everything is correct, then it should work. So let me paste in the R1. Let's see, everything is good. Yes, everything is good, no error. Okay, now I move everything here. So now let me copy the switch configuration. From here to here will be switch configuration. I will copy this. I will go in the switch. So where is the switch? This is a switch. Switch will have the duplex this issue. No problem, we can fix that one also. But the configuration what we put, everything is good. Okay, everything is working perfectly. Only we will have the interface issue. So I can do that. I can make like interface range E0 by 0 dash E0 by 2, and I will write E0 by 2 or E0 by 0 dash 2, and then I will write a half duplex half. Just for lab purpose I am changing, so we will not have the error. Okay, so I done in the switch configuration. Now we will do for the ISP1 and ISP2. So this is ISP1. I will go to the ISP1. Where is the ISP1? This is the ISP1. So just I need to paste the configuration here in the ISP1. Okay, everything is good in ISP1. Now I will take the configuration for the ISP2 and I will paste in the ISP2. Here this is ISP2. So I will go here, I will paste here this one. Okay, everything is good. Now we have the two routes. We can go in the our router customer edge and we can check here. If we check here, show IP route, if you see here we are getting the static route. This one we are getting from the ISP1. okay, now we are getting this one from the ISP1. Imagine if I make this ISP interface done. This ISP1 is having which interface? Show IP interface brief. So ISP1 is having this interface. If I make this interface done, our route will not change. If I go here in this interface and interface, if I go inside that interface and I will write shut, okay, I will make that interface done. And if I check here, this interface is done here. This interface is done here. Okay, ISP1 is done. But if you see in our customer edge, if you see show IP interface brief, our interface will be up only. If you see, this interface is up, this interface will be up, and this will not remove from the routing table. If you check also show IP route, you will have this one only. But if you ping, it will not work. If you ping 1.1.1.2, it will not work because this link go down. Because this link is down, this link is down here. So what we can say, default route or static route is unreliable. Means if they are only checking the directly connected interface. If this one is up, he is thinking this is up. Even if this ISP go down in our routing table, this will not change. This is saying ISP is up only, but when we try to access, it is not working. Okay, so in that scenario we will have the issue. What issue we will have? If this ISP is down, this ISP is down, even though it is present in our routing table, it should remove, but it is not removing. In real scenario also we will have these types of issues. So what we can do, we need to use the IPSLA to fix this issue. Let me bring first of all this ISP interface back. So what I will do, I will go to the global configuration mode. I will write interface F0 by 0 and I will write here no shut. Okay, I write no shut. I will save this configuration. Now if we ping in the, let me save here also for the ISP2. Now I will check in the customer edge. If you see, now it will work. This is now it is working because this interface I came up. But the problem, if this interface go down or anything happen here, example what I am saying, we are here, okay, we are here. Now by default this link is active. If this link go down, automatically this traffic will switch here, but it is not happening because we configure default route, that is a static route. We configure static route, that is a special static route, that is a default route. So default route is a unreliable. It is not reliable because they will check the directly connected link. If the directly connected this link is up, they are thinking everything is good, but the issue this is down. In real scenario we will have switch or mux or demux. It is not directly connected in the real scenario. So to overcome these types of issue, we need to configure the IPSLA. So IPSLA is going to ping this IP continuously. If this IP is he is not getting reply back from this IP, automatically IPSLA will move the route from that to here. Okay, so what we need to do, we need to remove the default route. So I will remove the default route. First of all, I will write here no. Okay, and I will write here no. So this way I will remove the default route first. From where? Customer edge. So I will go here in the customer edge. I will write here global configuration and I will remove the default route. Let me copy this. I will remove the default route now. So now I remove the default route. So if I want to configure the IPSLA, how I can configure? So steps is very simple. I can write here. Let me configure here. Sorry, let me move this no shut here. And I can do here. So in the IPSLA, when we are configuring IPSLA, we need to write IPSLA. Any number we can give. I am giving one, IPSLA 1. And which one I want to use? ICMP, echo, ECHO, echo I want to do. What I need to ping? I need to ping 1.1.1.2. I need to ping the ISP. If you see here, this IP I need to ping. So I am saying IPSLA, ICMP echo, ping this IP. Okay, ping this IP. And I am saying source IP, our IP. What is source IP? This one, 1.1.1, this IP. And we can say frequency, how much time he need to ping. 10, we can say 10 seconds. Every 10 seconds he can ping. And timeout we can define. Timeout will be in milliseconds. So 500 millisecond or 5000 millisecond. If it is not replying till 5000 millisecond, we can say this is done. Okay, so what we are saying, we are creating IPSLA. We are saying we can ping to this IP, this ISP IP from here, and every 10 second ping, and timeout will be 5000 millisecond. Okay, we define this way, and then we will write exit, and then now here we need to apply. So I will write IPSLA, and then we need to create the schedule. So I will write schedule number, anything we can give. I am using one, start, and start time we need to define. If you want to give time, we can give, or we can say now only, and till what time? Now live forever, means till what time it should work. So forever, now till every time it should work. And we will write the track. We will write track command. So I will write here track. I will give track number 1, if we can give anything, and then IPSLA, and here we need to give the same SLA number. If you see here, we use 1 here, so same number we need to define. So what we are saying here, we are mixing that one. We are saying schedule 1 start now and run forever, and track number we are saying 1, and he's saying check the IPSLA 1. And after that, what we will do, I will define the route. I will define the static root. If you see this one, we can copy and paste here. I will go here, I will say, I will remove this, I will say static root IP root 0.0.0 0.0.0. Then here I will put here, instead of 5 I will write track 1. So he will track that interface, this IP, whatever they are pinging. If it is not working, then they will move to other one. So other root I will define here. So I will move, I will cut here, I will paste here, and no need to remove no here. Okay, so first root is going to track. So this is the IPSLA configuration. Anyhow, let me type and show you. This is the customer edge. So we remove here. So I will write here IP, okay, IPSLA. Okay, IPSLA, then I put the question mark. So what I need to do, I need to put the number. So I will write IPSLA 1. So now I am inside the IPSLA. What I need to do, if I press question mark, so many things we can do: DHCP, DNS, Ethernet, exit, frame relay, HTTP, echo reply. So we need to use echo reply. We can use ICMP jitter, we can use path jitter, so many things we have, but now we will use ICMP echo. So I want to do ICMP echo. So I will write ICMP echo. From where I need to echo, we need to give the IP address. Which IP address? Destination. Destination means our ISP IP. So I will give 1.1.1.2. After that, if I put question mark, source IP or source interface. So I will write here source IP we can give. Okay, source IP. And what is the source? From where I am pinging? 1.1.1. I am pinging from 1.1.1. Okay, if I press question mark, nothing, just press enter. After that, we need to define the frequency. Frequency means how much time. I will say 10 seconds. Every 10 seconds they will ping, and request timeout should be 5000 milliseconds. This is in the milliseconds, so I can give any time. I will say 5000 milliseconds. Exit, and then I will write IPSLA, and then schedule, and schedule number I can give anything. I will say start time now, live forever, till forever, and I will say track I can give the track 1, and then IPSLA SLA I can give SLA number 1. Okay, let me check here, something wrong here. Let me check IPSLA schedule 1. I will press question mark, IPSLA schedule 1 live forever I will use. After that I will press question mark. So how long to keep this entry inactive? So I can say here forever. Okay, and then I can say here track I will give track number as a 1, and then I will say IP. If I press question mark, SLA. So IPSLA, what I need to give? SLA number. So I will say track this one. After that I need to define the root. So I will write IP root 0.0.0, then 0.0.0. I need to forward to 1.1.1.2. Okay, I need to write track also. Track which track? Track 1. So this way, and then I will write IP root, and then 0.0.0, and again 0.0.0. I need to write here a second ISP 2.2.2, and the ID value we are saying 10, so we will give 10. Okay, so this way only. Let me put here enter here, this one. Okay, so this is the configuration just now what we done. So now this guy, now let's see here. I will write here show IP root. If you see in our root we have this one. Okay, by default we have this one. And now if you trace 8.8.8, it will go from the first one, or if it is taking long time, we can use the direct IP. Let me show, let me cancel this one, star shift 8, or it will take long time. Control X or something we will press here. Okay, now it is going from the ISP 1 now. If you ping, example I will write ping 8.8.8.8, it is working. Now I want to show you, example I wrote here show IP root. When I write show IP root, you are getting the root what we are getting. This is from the ISP 1. Okay, how I know ISP 1? Because if you see 1.1.2, But now imagine I will go to ISP1, I will make this interface done. Okay, show IP interface brief, ISP interface, I will make this done. Interface fast Ethernet 0x0, I will make this as a shut. Okay, I make this interface down, so link will go down here. So here in our routing table this should be changed, and this we should have the ISP2. So now if you see, we have the ISP2. Automatically it is changing. Before it is not changing. If you see, and if you see, you have the notification also. IPSLA state is up, then it moved to down. So what we are saying, SLA go down and automatically route change. And if you want to check also, we can check. How we can check about the SLA? We have the some command here. I will write here, show IP SLA static. If we see here, this is a SLA forever lifetime, and it is fail 4 times, 4 packets fail, and we are using ICMP. And here timeout successful is a 14 and the fail one is 4. Okay, so this way we can do. And most important thing you can check is show IP route. You write here, you are getting this route from the ISP2. Okay, if you do trace route also 8.8.8.8, you will get from the ISP2, not from the ISP1. So what automatically it is changing. Before it is not changing because the static route is a, what we can say, reliable. It is not reliable. So for that purpose, what we will do, we will configure the IPSLA. So when we configure the IPSLA, IPSLA is going to track the ISP. Okay, if you see, it is coming from the ISP2. So IPSLA is tracking the ISP. If you see, this is from the ISP2. And now I will go here again in the ISP and I will make this interface no shut. So then again it will come back. It will come back. Now if you check here, it will come back again. After some time they have the timer. After that it will change. Okay, it will change. So let me check here. We make the interface up and we will check here, do show IP interface brief. So now this interface is up, and now let's see our customer edge. Where is customer edge? This is a customer edge. And if you see here, you get the notification IPSLA 1 before is done. Now it move up, and now if you check the route, it will move from the ISP1. This is a ISP1, AD value is 1. Before, if you check, this is from the ISP2 and AD value will be 10. Okay, and if you run the same command just now what we wrote, this one, if you see here, it will show this is the OK. Before you are getting here fail or done something. Let me check what it is showing. If you see timeout, before when it is IPSLA is done, it is showing timeout, but now it is saying OK, and 18 successful, 12 fail. Before we have fail also. So this way we can check IPSLA is working or not. Here we can configure so many things, like how many milliseconds it is taking to go and come back. We can measure the network performance also. But in the real scenario, what we are doing in the real scenario, we are using this for the ISP purpose. Example, if we have the 2 ISP, we will use this. This is the real scenario we have in organization like this setup also. So just remember, I use the simple here. Instead of 5, we will have the different VLAN. Like 5, 2, 3, here we will have the 6, 8, 4, something different number, but and different IP. But for the lab purpose, I use this one. So this is very easy and very simple. Just you need to understand the concept. I have 2 ISP, and you need to remember ISP, this is a different ISP, and this is a different ISP. They both should not give you same IP. This ISP will give you different IP. This ISP will give you different IP, but you have only one port. How you are going to terminate? In this place, you will have the Palo Alto firewall. How you will terminate? We will use the sub interface. We can create the sub interface inside the Palo Alto firewall also. Okay, so what we can say, we can use the sub interface, and we will make the sub interface. Before that one, we will put this in the one VLAN, any VLAN, here different VLAN, and here we will create as a trunk, and we will create sub interface. We will assign this IP. We will configure the default route by using the IPSLA. So if anything go wrong here, automatically it will change. Okay, before, what issue we are facing, if this link go down, even if it is go down, our default route is thinking this link is up, so it is thinking everything is good. okay, because default route is not reliable. So that's why we have the issue. So when this link go down, even the routing table is not changing route from here to here. So we use the IPSLA. IPSLA is pinging this one. When this is reply is not coming, automatically is changing to this one. Okay, I put everything in the notes, so when you study the notes you will have the idea. Let me show you before closing that one. Where is the notes? IPSLA, this one. So here if you see, first I create the simple topology here. You can this one I am pinging from here. So in this one router we use, I put all option. When we write IPSLA question mark, whatever the option will come and which one we are selecting, I put in the bold, and all that option we configure here the basic lab. Okay, and then main scenario where we are using in our organization, this is a scenario I put here, and all configuration, all the theory I put here, why we are using, why we are creating sub interface, why we are putting in different VLAN, everything you will get here. Okay, and this is a testing. We make that interface down from the ISP. So this is a route. Before we have the different route here, now it is different route, and this is the IPSLA. We can check. You will have timeout if it is fail. If it is working, you will get the okay. So this is a IPSLA. So this one we finish. We have configure and verify IPSLA. In our next class we are going to start this one, span, RS span and ER span. Okay, so let me